Hello and Assalamualaikum. Today we went to present about JFET. What is a JFET? JFET is a field effect transistor and it's a terminal device. It can be used as a switch or amplifier. It can be classified in two categories. There is N channel and P channel. In N channel, the generation of the current is due to the movement of the electron. In P channel, the generation of current is due to the movement of hole. Since the movement of electron is faster than the movement of the N channel, JFET is preferred more than the P channel JFET. JFET has a three terminal drain. There are source, gate, and equivalent to the collector, base and emitter in BJT. In BJT have a PN junction, but JFET have a channel made of either P type or N type. In P channel JFET, arrow point outside and N channel JFET arrow point inside.
Okay, net fixed by a JFET circuit. A constant DC voltage is applied to the gate terminal to control the current flow. This voltage keeps the gate source junction reverse bias, ensuring that the JFET remains in operating region. The source terminal is directly ground. A resistor RG is connected between the gate and ground with a DC voltage source VGG to provide a fixed gate source voltage VGS. How it works. The gate source voltage VGA is set by the external voltage VGG. Since the gate is reverse biased, no gate current flow. Ideal condition, so VGS remains stable. This stable VGS keep the drain current ID constant as well.
Servicing is the circle automatically set up the proper gate source voltage to establish the desired operating condition. The first thing first to do the circle diagram is first set up the circle. The second one is establish the bias voltage. The third, maintaining the operating point for maintain established bias automatically. And lastly, we have a stability to provide a thermal stable for the temperature in the circle. For the component, we have a three component to do CR base. The first thing first is a transistor, a resistor, and lastly is a power supply.
Example, self-biasing and channel JFET amplifier circuit. Circuit components and setup: JFET, drain resistor, source resistor, gate resistor, and supply voltage. For circuit configuration: drain, gate, source. How the circuit works: voltage draw across RS for self-biasing, setting the operating point and feedback mechanism.
Hi, Assalamualaikum. My part is about voltage divider biasing. Voltage divider biasing is a typical approach used to create a steady bias voltage on a transistor so that it function in its active region. First is circuit diagram. First point is about voltage divider resistor R1 and R2. R1 and R2 are connected series between the power supply, VCC, and ground. And the second explanation, midpoint between R1 and R2 is connected to transistor, and the last is the point set the base voltage. The second point is about transistor NPN. The collector connected to VCC and through the RC. Base connected to the midpoint of R1 and R2. Emitter connected to ground through RE. And the last point is collector and emitter resistor. RC limit the collector current to help define the collector emitter voltage. We see RE provide the thermal stability by creating feedback that contract the change in the transistor operating point due the temperature variation. The last point is about the last component. Have three transistor, resistor, and power supply. For the transistor, we have NPN like BC 547 or PNP BC 557. The resistor R1 and R2 to create the voltage divider, such as RC, RE. RC is collector resistor, RE is about emitter resistor for stability and to get the set the emitter current. The last is power supply. Power supply is VCC to typically DC supply, 9 voltage or 12 voltage, depending on the resistor rating. That's all from me. Thank you.
JFET are highly valued in electronic circuits due to their high input impedance, low noise characteristic, and efficient voltage control operation, making them ideal for a variety of applications, including amplifiers and signal processing. However, designers must account for their sensitivity to variations in manufacturing parameters and temperature to ensure stable and reliable performance. With proper design considerations, JFETs offer exceptional benefits in circuit requiring minimal signal interference and precise control.